session. Okay, great. Okay, again, we'll continue with study unit 5. I don't think any of you have received any formal feedback on assignment 1 yet, and I also haven't. So we'll just continue with study unit 5, and then when we get that official feedback, we'll work in that session as well. Okay, so basically this morning we're going to continue with study unit 5, where we look at the discrete probability, binomial and Poisson probabilities. So I think what again is important, but you have that now on the PDF that I shared in the WhatsApp group. If you haven't received it, just give me a WhatsApp and I'll send you all the study summaries that I've done thus far. So from chapter 1 to 5. And if you're not on the group, you can also just send me a WhatsApp and I'll add you to the group. Okay, so let's continue. So what you will see, and again, just how your exam will be structured, I think that is also important. So the first 5 study units is normally your first part of the exam. So your exam will be divided into sessions. Normally, the first part is 12 or 13 questions on study units 1 to 5, and the second session is then 12 or 13 questions on the rest of the study units. So that's why your assignment 1 and 2 is nearly your first session. The rest of the assignments is your second session. So what you would have seen now nearly is that in each of the study units, there will be 1 or 2 questions. And that's why in study unit 5 is normally 3 questions to make up the rest of that 12 or 13 points, because we have 3 distributions in here. Okay, so when we work with discrete probability, the first thing is they would need to give you a table, because for Poisson and binomial, we have tables. It's in your study guide. Quickly, the old study guide that I also still have. So the binomial and Poisson tables is in your study guides. Again, it's open book exam, so you will have your study guides available to use that. So that's not going to be a problem. But for a discrete probability, they need to tell you how that discrete probability looks like. Else you can't do anything. So then there's a few things that, and it might be in another question. I just want to check, else I will put one of those questions. Okay. So also with discrete, as we know with all the other probabilities, it always needs to add to 1. So that's why you'll see that they can give you data and then keep 1 open, because with that you are then supposed to know, well, all those probabilities needs to add to 1, so we can work out that 1 probability that's left out. If there's 2 probabilities that's left out, again, we won't know, because we can't just assume we will split it up equally or anything like that. So they can just leave out 1 of the probabilities so that you can work it out. But let's go to the first one. So they tell us which of the following statements is a valid probability distribution. Okay, so they give us x's, then they give us the probability. So in this, they actually going to test with us if we know that the sum of all these probabilities is going to be equal to 1. So that is what they are testing with us. So let's and there I need a calculator. I just want to see where's my calculator because it's too early to make these these sums. So let's check. So it is 0.512 plus 0.384 plus 0.096 plus 0.008. Okay, and that, if I add all of that, it is equal to 1. Which one of the following statements is valid? Okay, so in the exam, that would have been my answer. I would not even go to the others to check if something is wrong, or because time is limited for you in the exam, so I would have stopped and gone to the next one. But let's just, for interest's sake, check the others. So this is the easier one too. So 0.1 plus that is 0.4, 0.8, 0.9. Okay, so that can't be because it needs to equal to 1. Let's look at this one, 0.98, so that would be 0.99, 1. So this one is 1.01, also not valid. Okay, yeah, it becomes tricky again. So that one plus that one is 0.7, 0.7, 0.95, 0, okay, so this one will again be 0.99, which is just below 1, so it is also incorrect. And this one will be 0.3, 0.8, that's a point, so 1.2. Okay, so which also makes it incorrect. So here we actually have tested that the probability of a discrete function needs to add to 1. Okay, so a nice, easy one to first start off with, so that we don't need to really calculate anything yet. Any questions? Yes, cool.
Hi everyone. Jean, I'm actually still a bit confused. Just this one. Just explain it again for me.
Okay, so and it's interesting. I don't even know how a discrete distribution looks like, but I'm just going to draw and let's say that is your discrete distribution, but it's actually, so let's draw it how it. So they give us a distribution and nearly it as bars. So and I'm just going to draw that one, and it doesn't need to be on size now. Okay, so basically what the rule is that this probability of all the bars of your function, that probability needs to equal to 1. So when we get to study unit 6, we will work with normal distribution, and then the rule is that below your normal distribution, when we look at probability, that equals to 1. So that's always the rule with any probability that if you look at a probability function, you look at the distribution of it, it needs to equal to 1. So out of these questions, you basically need to check which one equals to 1. So when you add all of those together, all the probabilities together, which one of these is equal to 1? So that is basically what we're doing. So that one, let's say that was 0,512, that was 0,384, that was 0,096, that was 0,008. If we add all of those numbers together, we get 1. So then we know that first one is the correct one. And so if we do it with those numbers, we get 0.9. If we add those together, we get 0,01. We add the fourth option, all those together, we get 0,99. And if we add the last one, all of those together, we get 1.2. So we know then that none of these is correct.
Okay, thank you so much. Makes sense now.
Okay, cool. Yeah, so please ask, because I think that's the purpose of these sessions is, so if you don't understand, please ask, because this study unit is very important, nearly study unit 4 and 5, to get to grip with your probability, because study unit 6 just builds onto this, and then study unit 7 builds onto that, and 8 onto that. So it's very important, nearly, and that's why I don't mind standing still a bit with study unit 4 and 5, and getting you to understand that much better, because the rest just becomes a bit more difficult every time. So let's rather spend time on this. So even if we don't finish this today, we'll finish it next week, but it is, and then it's still in time for you to actually complete your study unit or your assignment too as well, because I think that only goes live on Thursday, if I'm 100% correct. Okay, so we're going to do this the same.
Thank you.
Cool. So basically, we now know that all the probabilities for your discrete needs to add to 1. So now they can start asking you a few other questions. So once again, they need to give you how the distribution looks like. If we're looking at discrete, again, they can't just say we're working with data. They need to give you that table. So now we can get a few different types of questions. And I think what is important, and I just want to see if I can quickly copy this in here, just as extra. Okay, see, so there we had that equal to 1. So I just want to make sure that we nearly, because again, it is for you open book. So you can also use this slides and print it or have it with you at any time, so that we know if they ask us something about the mean, and I'll nearly copy that through to all the other questions. So when we work with discrete, we know the first question was the sum will be equal to 1, but then they can ask you other things about discrete as well. Okay, so let's get to the first one. So they ask us the probability that x, so when we look at the probability of the x, and the probability of x bigger or equal to 2, so basically they're asking us, what is the probability when your x is bigger or equal to 2? So by that, you need to say, okay, well, we look at it from 2, 3, and 4, and we need to add those 3 probabilities. And if it is the same, lucky, and we can stop at this point. But we look at it 0.5 plus that will give us 0.7. So unfortunately, that one is incorrect. Okay, so I'll each time use a different color nearly to just show what they are nearly asking in that question. Probability that x is smaller and equal to 1. So smaller and equal to 1 means that you are including 1 and everything below 1. So x1 and smaller is basically 1 and 0. So if we add those 2 probabilities together, we get 0.3. Okay, let me just do that over. We get 0.3. And then we know that one is also incorrect. I'm going to leave that one for last because then we're going to use this formula. So I first want to check. And again, that's how if this was me writing this in the exam, that is how I would have done it in the exam as well, is because that's a more complicated answer that you need to work out. So I will first look at the easiest things to do, so that in the exam maybe I don't even need to work that out. Okay, so let's look at another color that we just bring in. So what we see here is x that is smaller or equal to 4. So let's take it from smaller or equal to 4. So we're going all the way, but we go bigger than 1. So bigger than 1 does not include 1. Okay. So now look at what was interesting is, so that is correct. So this and this, these two questions look at exactly the same area, 2, 3, and 4. But look how different it was set in this question. So it's looking at exactly the same area that it is covering, but you can nearly see that there's a few ways that they can ask this question. So they could have also said, but what's the probability that x is bigger or equal to 2, smaller or equal to 4? That would have been exactly the same because bigger or equal to 2, smaller. So again, that would have been exactly the same. So another way that they could have phrased it to get to the same answer. Okay, so let's look at the last one and bring in another color. So x smaller than 4. So it doesn't include 4 because it's smaller than 4. It's not equal and smaller than 4. So it does not include 4. Bigger than 2. So again, it's not bigger and equal to 2. It's only bigger than 2. So it does not include 2. So it's only that, so it should have been equal to 0.15. So out of these nearly, we could have seen that option 4 is the correct one, and we did not need to work out option 3, but let's do it. So here's the formula for that. So you need to do the sum of the x value times the probability. So we need to say, and that again, unfortunate that you guys are writing online, but how I normally do this is then to say, well, I need to work out the sum. So I work out so 0 times that gives me 0. 1 times that gives me 0.2. That times that, I think that is 1.0. That times that is 0.45. And that times that, I hope, is 0.2. And then if we add that together, we would have seen 0.2 plus 0.45. That is 0.65, 1.65, 1.85. Okay, they've got 18.5, so I think that is actually then correct. So this one is incorrect, because you can see it should have been 1.85 and not 18.5. So they could have now also said we need to work out the variance, but for that I will rather show you next week how we use the tables, or sorry, Excel, because what we now in this instance needed to do, so you can also try that as practice, but if we now needed to work out the variance, we would have needed to say, okay, the x, so 0 for the first one, minus the mean that we worked out, square root that, or square that, sorry, and then we multiply it by the probability. Then you needed to do it for the second one. And you needed to do it for that one, up until nearly the last one, which is 4 minus 1.85. And then if we add all of that together, we get the variance. And if we then square root the variance, we get the standard deviation. So that is a lot of work to do if it is in the exam. So I'll rather that you can practice it when it is in the assignments or stuff like that. But I think when we get to the exam stage, I rather would that you use the Excel to create that, because it's a lot of work to to do that in a short time. Yes.
I'm still a bit confused regarding the first standard deviation, not regarding the one that we're doing now. I have an idea of what's going on, but also when we have time next week, just want to start with the standard deviation from, I think, unit
Study.
2 or 3.
Yes. Yes. So that's why I'm nearly waiting for that feedback, that we can cover all of that as well, because there I want to nearly show you also the process, how we would do it, but then also the process on Excel, so that one can nearly have that to your advantage, because I'll update this sheet, I'll share it with you guys, you can use it, you can build your own things as well. So yeah,
Thank you.
happy to do that. Okay, so there's still going to be a few on discrete, and now you can see it. There's only so much that they can ask on discrete. So they can ask you basically, if we go to the definitions, there was the first question that we looked at, where the sum needs to be equal to 1. The second question was that we needed to all verify what the probability is of certain numbers, and we needed to work out the mean. So the only other thing that they can ask is the variance or the standard deviation. So let's just check where that will come in. So not in this one yet. Here they ask us to do the mean, the expected value. So I'll do exactly as I did in the previous one. I just multiply it out and add together. So 0 times that is 0. 1 times 0.2 is that. 2 times 0.1 is 0.2 again. 0, I think that is 0.15 plus 0.12 plus 0.05 plus 0.06. So if we add all of that together, we would get one of these answers. So 0.2 plus 0.2, 0.4, 0.55, 0.67, I think, 6772778, 0.78. Okay, 0.78. Okay, so but this is nearly straightforward from the how to work out the expected value. They tell us as well what you need to work out, so there's nothing in this one that was confusing. It's straightforward. So yeah, so that is how to work out the expected value on the discrete. Okay, so I think this will be the lot. Oh no, there's still 2 on discrete. Okay, so let's just make 100% sure about the probabilities. So which one is incorrect this time? So let's start with x bigger than 1. So x bigger than 1 does not include 1, so it is 2 and 3. So we see that is 0.35. Okay, so that one is correct, but we're looking for or the incorrect one. Okay, next color, 0x smaller or equal to 2. Smaller or equal to 2, so it includes 2, goes smaller than 2, so it's that free, so that's 0.6, 0.85, correct. Okay, so let's look at x bigger and equal to 2 and x smaller or equal to 2, x bigger or equal to 1. So it basically looks at 2 and 1 because it's smaller or equal to 2, bigger or equal to 1. So it only looks at those two, and that is also correct. Okay, sure. You need to work through all of them. Okay, smaller than 1. The smaller than 1, basically it does not include 1, so it's only 0. So smaller than 1 is 0.25. Okay, so we actually only left with the last one that needs to be incorrect, but let's look at that one as well. Smaller or equal to 1. Okay, so it's definitely we include 1. Bigger than 0. So we don't include 0, so we're only looking at 1. That's why that one is wrong, because it should be 0.4. So what they did is to say, well, include that. So that's why it was wrong. If it was looked like that, then we would have said bigger or equal to 0, smaller or equal to 1, and then it would have been including both. But it didn't, so that is why option 5 is incorrect. Are you comfortable in the way now to nearly work out the probabilities if from the table? Okay, cool. Okay, so yeah, just let me know if at any time I need to do another one. So here's the last one of discrete. So here they're now testing both things. So they're testing that, let's just take that away. So they're testing that you know that the sum needs to be equal to 1, and then they test you to work out the mean. So what, again, I would just do the calculation of the mean. Yes, so let's do that. Sorry. That needs to be a E and not the sum sign. Okay, so first let's work out what that value should be. So it is 0.05, so that's 2.2, 2.6, 2.8, 2.85. So that should be 0.15. And you will, and it's very difficult to note it, because you could have now gone through this, work out with 0.15, and then we're like, okay, wasn't that what I was supposed to work out, without looking at really what the question is. And again, one is forced in the exam to be quick, and you can very easily say, oh, 0.15, I got it, next question. Okay, so just be careful when that you don't select that as the answer because it was there. So we still need to work out the expected number. So let's do that. 2 times 0,05 will be 0,1 plus 0.6 plus 0. Or 1.6 plus 1 plus 0.9, I think. Okay, so if we add that together, we can see 0, 0,1, 0, 0,7, 2.3, 3.3, 4.2. If I add all of that together, 4.2, which is then option 5. So just be very careful when in your assignments and in the exam if there's a and that is, so if you look at this now, this is a perfect example of where in the assignment this year they giving weird marks, like a 1 mark for a question that is supposed to be 4 marks, and your answer isn't correct, because they would have now in the assignment, if you said 0,15, they would have probably given you 1 mark, because that is what you calculated there. So in a sense, they would have said, okay, you're on the right track. If it was in a paper-based space, and I think that is why they are doing that now with stats, is it is 4 marks or 0. So if you were writing it and it was not multiple choice, you would have probably gotten a mark in any case then. So we're trying to move in that direction. There's a question. I think over King, I think it's your hand that I'm seeing, if I'm correct. You can ask. I think you're still on mute, so you can, but you can ask later as well, and I can go back to the question if there is. Yes. Okay. You can see later if connection is better again, and maybe we can then just ask again. Okay, so the next set of questions is around binomial. Yes, go.
Hello, can you hear me now?
I can hear you now.
Okay, thank you. Much better. On the previous question, I didn't understand very well. How did you get the value of day 6, the probability of day 6? Did you add all the days?
Yes. No. So what I did to get that probability, remember, the sum of the probabilities need to equal to 1. So I said 1 minus the 0.005 plus 0.2 plus 0.4 plus 0.2. So that would have been then 1 minus 0.85, which would have given me the 0.15. So that is how I worked it out. So it's
Okay,
basic.
thank you.
So basically, just remember all of these need to add to 1. So if there's anything missing in there, you can just say 1 minus all of the rest, and you will get that missing number.
Okay, thank you.
Cool. Happiness. Okay, so let's then start with binomial. Let me just go back to the slide on binomial. So in binomial, basically, where is, okay, I must include here, okay. So in binomial, you basically, there's three things again that is important to note. So we will, I just want to check what is, okay, so the one, as always, like we did in the previous one, is we'll look at probabilities. So we will always have a probability like in discrete to look at. Then we will have a mean that we can calculate and the variance that we can calculate. With this, and you'll see, I included this table. So with binomial and Poisson, you will not get the table as this in the question. So you will need to, they normally give a formula pack beforehand, or they will say, but in your study guide, the tables are there in any case, so that you can use it from your study guide. But they will not nearly give you the table in the question. So I just copied it into the question because I don't want to go back to the book and then back to the question and things like that. And again, it's easier now to nearly explain if it's copied in what we're looking at. So in the binomial, they will tell you it's a binomial random variable, so that you know you need to work with a binomial table. Then they need to give you two things. They need to give you the n value so that you know, and we can show it here as well, because you need to know which n you're going to work with. So they need to nearly show you, they need to give you what the n is so that you can go to that table. So that's why this one I already copied in. We know what n is, so n is 6, so we work with the n table that is equal to 6. And then the other thing that is important that I need to tell you is what is nearly the pi that we're working with here, nearly to say how we're going to work out the probability. So they tell us it is 0.2. So we know then if it's 0.2 that we're working with this column. So again, if I was in my study guide, I would have said, okay, here is the N6 that I'm going to work with. I would have gone to where that is. So I would have said that would have been my group of probabilities that I will work with. So again, just it is in your study guide on page 90. It's in the textbooks. You can even go to binomial, a binomial calculator on a website. There's a few ways to do this. So now that we know what we're working with, now we will have, again, the same process. We will look at probabilities, then a possibility of working out the mean and the possibility of working out the variance. So let's look at the first one. Probability of x equal to 2. So there's x2. So probability of x equal to 2 is 0.2458, which is correct. And we're looking for the incorrect statement. I'll just use a bit lighter colors. Probability x equal to 5. Again, go down, x equal to 5. Go across. So x equal to 5, 0.0015. Okay, that is an incorrect one. Okay, this was actually, I thought there would have been something different. Okay, so that is your incorrect one. Okay, let's look at the next one. X smaller or equal to 1. So remember, smaller or equal to 1, it is then 1 and 0. Smaller or equal to 1 is those two numbers. Let me just calculate it. 0.2621 plus 0.3932, 0.6553, 0.6553. Okay, so that one is correct. Then bigger or equal to 5, probability bigger or equal to 5. Let's just use another color, bigger or equal to 5. So it includes 5, so it will be 5 and 6. So it is those two. So you can see here it's 0.0016, which is correct. Okay, so that was to work out the probabilities. Then for this one, for the mean, this is a very nice, I like it to work out the mean of a probability. So in the exam, I would have worked out that actually first, because this is a very easy one, even though it wouldn't have been the one to eliminate. N we know is 6. The pi we know is 0.2. So 6 times 0.2 gives you 1.2. Okay, so that the mean and the variance for binomial and Poisson is actually the nicest ones to work out first, because that's the easiest. So very similar to discrete, in the sense that we go to the table, we work out the probabilities, a bigger and equal to, a smaller or equal to, there could have been just a bigger than or just a smaller than, but very similar to the discrete. So that's why, again, I would rather that you practice to use the table than going to use this formula. Because again, if you could have used this formula to work out probability, but this is a nightmare, because it just create, and I rather again nearly built that formula for you in Excel, that then if you get the n and the x and those kind of things, that you can work it out in Excel. So I'll add that to the Excel, because again, if you need to do this in the exam for any of these, so if you needed to do it for option 3, you would have needed to do it twice. So imagine if they have at the question x is smaller or equal to 4, or let's say 3, because that's nearly slam bang in the middle. So if I had that, and you needed to work that out with this formula, you needed to do it for the 0, the 1, the 2, and the 3. So you then needed to do it 4 times, and then it is, trust me, it is absolutely chaos, because then one small thing can lead to a mistake. So binomial, Poisson, both please use the tables, and we'll do enough of these tables throughout all the sessions that we will know how to use it in the end of the day. Yes, Bongani.
Arjun, can you please just assist with number 1? How come we say px is equals to 2 is equals to 2458? How did you get that one?
Okay, so that was straight from, and I think what sometimes is difficult is to just do, and that's why I also use a ruler in your, when you're in the exam or when you're in the assignments, because it is going straight, and there you have it. Okay, so we're only looking at x equal to 2. So
you look for any value that will be positive for under x is equals to 2.
yes.
Okay. All right.
And because we're working with
Or the 0.2, yeah. Okay.
we know it is in that.
Okay, no. Thanks.
So what I also normally do, because you would see now in your study guide how this goes. So if I would always have a ruler just with me, because now you're working somewhere here, maybe with another one, and then a lot of time one makes the mistake of you go, and then suddenly you get here and you're like, okay, let's pick that one. And you would not in this one, but maybe there's a different one. So let's look at, I just want to see, okay, so this already then goes into, I just want to check, because sometimes what happens is they will give you, say, in this, maybe to look at the incorrect one, they could have given you the 0,0819 or the 0,3932, just because to nearly keep that balance, to get to that far end, one can easily just move one up and down as well. Okay, so
Thanks.
cool, perfect. Let's last one of the day. So a certain type of tomato seed germinates 90% of the time. A backyard farmer plants 25 seeds. The expected mean. Okay, so here we actually have a very, this for me is a very nice one, because it is, they just want you to work out the expected mean. So no tables, no worries of other probabilities. They give you n, they give you the pi. So all that you need to do is to say, to work out the expected mean is n times that, which is 25 times 0.9, and which is 25 times 0.9, 22.5, which is option 5. One thing, please, when you do this in the assignment also, and also in the exam, just be very careful when you read the questions, because I have seen in previous papers that, so they give you the same question, with a certain type of tomato seeds germinates 90% of the time. Then they say a backyard farmer planted 25 seeds. Then they change the question a bit. They say the expected number of seeds that does not germinate. So if they say does not, I don't know what is now going on with my gestures. So if I say does not, what do you do? I would this differ then if I say does not. Okay, so important thing with binomial is that an event happens or it doesn't. So one of the best ways of always describing binomial is when you flip a coin, and it can only be a head or tail. So every time it's just one of two things that can happen. So if I say does not, we know that does is 90%. So does not is exactly the same how we would have calculated that other one where we didn't know the percentage. Probability needs to always equal to 1. So 1 minus the 0.9 would have given us 0.1 for the does not. And then for the does not, the n stays the same, which is 25. The pi would have been now 0.1 and not 0.9. And then if they ask us does not, this would have been 2.5. Okay, so I'm just nearly again giving a tip because I've seen in 2 previous papers where they just ask for opposite. So they give you all the information, and nearly you think, because this was straightforward, but then they just throw in that one thing to upset the formula, and one doesn't really always pick it up. So I will also get you those questions. It was definitely in a previous exam, so I'll get that exam question for you. So I'm just making myself notes to get that for you and add it and show it later on. Okay, how does this help a bit? Is it starting to become clearer as we go along. I think with a discrete binomial Poisson, it's nearly step by step, very similar things that we work out. We just use different tables when we look at it. Okay, so next week we'll definitely finish with this. Then your study unit 4 and 5 are done, so then you are ready to do assignment 2, and that I think goes live on, I think, on a public holiday, so on the 16th. But we'll definitely, I know schools are making it a long weekend and everything, but we will definitely have a session next week, Saturday. I'll report again. No, we have not gone through assignment 1 yet. If any of you have received any formal feedback on assignment 1, please forward it to me. But I think the lecturer will make that hopefully available this week if he hasn't done it yet. But yeah, I just want the formal feedback that one can follow on that, and then we go through assignment 1 and we cover it in one session. So even if we make the session longer, we'll do that in one session. Okay, cool, everyone. Have a good. Yes, I'll definitely let you guys know when we're doing that. So have a good weekend, and we'll see one another again next weekend, and keep chatting on the WhatsApp group. Yes, Overking, you can quickly ask a question.
Okay, I just need to know how many assignments are we gonna have for statistics?
There's 5 assignments. If I remember correct from last year, I must just check how it's structured this year again. 5 assignments, they take your 4 best marks of those 5 assignments for your year mark, and then that is used when you write the exam at the end of the year as well. So last year it was 5 assignments, and of those 5 assignments, 4 counted, so your best 4 counted towards your year mark.
And after those assignments, are we gonna write the examination?
Yes, unfortunately. And your examination will be the same structure as your assignments. It is, you start at question 1, you end, you can't go back. So the structure of your exam is like the structure of your assignments. No time to turn back to a previous question. If it's done, it's done. You can't go back. So that's why I think it's important, and that's why they've done it this year as well, to make it that you get in that rhythm of how the exam will be.
Okay, thank you.
Cool. Thanks, everyone, and then have a good Saturday.
Thank you.